Hello and welcome to this week's Leetcode question. Today, Saidjahon Mamirov will solve the question linked list cycle. So,
Okay, so we're given the directions, given head, the head of a linked list. We want to determine if the linked list has a cycle in it. And there's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos, I'm assuming position, is not passed as a parameter. And we want to return true if there's a cycle in a linked list. Otherwise, we want to return false. So here we're given an example where we have a cycle because the tail of the linked list at -4 actually connects back to the 2. So it forms this loop. And so we want to return true for that because we found a cycle. Similarly, in example 2, 1 connects to 2 and 2 connects back to 1. So again, we have a cycle and therefore we return true. And in example 3, we don't have a cycle because actually we just have one node in our linked list. And so we return false. So my question is, are all the nodes in the linked list going to be unique?
you mean node values?
Sorry, yeah, node values.
Mm,
We know that.
I think we're not given that information. Um, imagine, uh, so so we are not given that information, meaning there might be a case when they are not unique, then, right?
Reason I ask that I think is because um what if we have like two zeros in our um linked list
Mm-hmm.
and say our linked list doesn't have a cycle though. We just have two zeros in the linked list at some point. Then if we see the second zero, I would like I would usually assume that that second zero means that we've like came back to that specific zero again. Like maybe we looped back to that zero. You know what I mean?
Mm-hmm. Yes.
Um, because I think a very simple solution to this question, it seems like um, we can store um, we can store all the visited um, node values in like a set of some sort. And then when we come across any one of those node values more than once, we have a cycle. That means maybe we came back to it. But if we assume that we uh, don't have, if we assume that we don't have unique values, that there is a possibility that we have duplicate values, we should take another approach then. Um,
Yes, there might be a case when they might not be unique.
okay, cool. So that's helpful. Do we also assume that we at least have a node in our linked list?
Mm. So the number of nodes in the list can be zero, meaning we might not have a node at all.
All right, so we might not have a node at all.
Hmm.
Okay, okay, interesting. Um, and obviously we can either have a cycle or not have a cycle, and we can have negative numbers. And it seems like we're not, this position value is not being passed into our function. It's just there, I'm assuming, for the test cases when our function is tested or our solution is tested.
Yes, yes. So you're absolutely correct.
Great. Okay, so I think I seem to understand the question. We have this linked list. We're trying to find a cycle. If we have a cycle, we want to return true. Otherwise, we want to return false. And we can assume that there could be duplicate node values in our linked list. Um, how are we going to solve this question? Currently, because my initial idea of using like a set to keep track of the values that we've seen doesn't seem to work with duplicate values. Um, Another approach we could take is a possibly like a two-pointer approach. And the purpose of having two pointers is if we have, say, for example, a slower pointer and a faster pointer, eventually, if we move the fast pointer, say, two times each iteration and the slow pointer one time, if we have a loop, eventually the fast pointer will come back around and catch up to the slow pointer, or it will surpass the slow pointer, at which point we now know we have a cycle. And so at that point, it doesn't matter if we've had duplicates or not. All we just have to look out for is that our fast pointer has at some point surpassed the slow pointer. And how do we know if there is no cycle? Well, that means the fast pointer has eventually gotten to the end or to the end of the linked list and it's none. And so that indicates to us, okay, we didn't come back around, so that means there must be no cycle in our linked list. So I'm thinking of using a slow and fast pointer approach. Okay. And I kind of explained what I was going to do, right? We want to define the cycle. We can check if fast pointer surpasses slow pointer. And so that's kind of the basic idea of how we're going to uh, implement this algorithm. So uh, I kind of feel comfortable with what I have right now. And so if you don't mind, I'm gonna start coding this up and cool. So let's go ahead and implement this solution. So like I said, we want a slow and we also want a fast pointer. And you said that there's a possibility that we don't have a node in our list, right?
That's correct.
So if we don't have a node in our list, is head just going to equal none?
Yes.
Okay, so I'm still gonna just set my slow and fast pointer equal to the head.
Okay.
Um, and I think this is a weird way. I think I have to do it like this. So this way we're gonna start both of our pointers in the beginning. And I'm not gonna think of the case where we have no nodes in our linked list yet. I'm just gonna focus on, say, example one, and then we can worry about the kind of edge cases afterwards. Um, so we define our slow and our fast pointer. And what's the idea? The idea is we want to iterate through the linked list. And how can we do that? We can do that while, like I remember I said, we don't have a cycle in our linked list if our fast node ends up at none, right? So as long as we have a fast node, as long as it's not none, right? And there's a possibility that fast next is also none. Um, while these two cases are true, that means we can continue iterating through our linked list. So for example, say this four actually goes to none and doesn't connect back to the two. if at some point we're at -4 and we move our fast pointer forward twice, so we say dot next, dot next. Well, we know that fast dot next is none, so we don't want to call this while loop again, because the whole point is to figure out if we eventually reach none. So these two conditions will help us have that conditional statement. So as long as these two are true, what do we want to do? Well, the idea is to move the slow pointer slower than the fast pointer. We can say slow is equal to slow dot next, and fast is equal to fast dot next, right? And once we do that, what do we want to do? Once we move our slow pointer and our fast pointer, what do we want to check? Well, we want to check to make sure now that, I guess, our slow pointer is let's see, we want to find, next up is we want to find when our fast pointer surpasses our slow pointer, or it's equal to our slow pointer. So we can maybe check that by doing if slow. How can I check this? So maybe, how can we check it? We can check if our slow pointer is equal to fast, is equal to our fast pointer, or slow is equal to our fast dot next pointer. So for example, in example 1, both of our pointers start at 3. In the next for loop, or in the next while loop, our slow pointer goes to the 2, our fast pointer goes to the 0, and then we go to the 0, and then the fast pointer goes to the 2, and then the slow pointer goes to -4, and then the fast pointer also comes to -4. So at this point, slow is equal to fast. So that's, in this case, we can return true. The reason I'm not checking slow dot value to fast dot value, again, because I think checking the value would not make sense if there's a possibility that we have duplicate values. So I'm gonna check the nodes instead, because these two should be the same nodes when both of them get here. Then also there's a case, the reason I did also slow is equal to fast dot. Oh wait. Or slow is equal to, this is not what I mean. What I'm trying to check, the other case is when, say, slow is right at this 2, and our fast dot next ends up going to this 0. At that point, we surpassed the 2, but I think eventually they do catch up, and eventually they do line up. So maybe I don't need to check both of them. Maybe I can just leave it like this. And so if we don't ever return true and we break out of our while loop, then we know that we don't have a loop. So we can return false. How does this work? Say, for example, 3. So both of our slow and fast pointers start at 1. And then we check while fast. So fast is 1. But we also have to check that fast.next exists. And in this case, fast.next does not exist. So we automatically break out of the while loop and we return false. Right? And so I'm going to just quickly put this as just quick review of what we've done. And then finally, let's look at example 2 maybe. So both of our pointers start at 1. And then while fast and fast.next, so they both exist, we can say slow equals slow.next. So slow becomes to the 2. And then fast is equal to fast.next.next. So the fast goes to 2 back to the 1. Now we check, is slow equal to fast? No. So we go back to the while loop. The while loop condition is not met. So the slow moves to the one and our fast moves back to the one again. And so now they're equal. So we return true. And then, so this example also works. And we already went over case one. This one, they meet at the -4, I believe. So that's the solution that I have. Quickly, though, I do want to mention some time and space complexities. So, in the worst case, we actually have to go through this entire linked list at least once. And so we would have a big O of n time complexity, even if we have to loop through our linked list more than once. That's still worst case of, say, like, 2 times n or something. And that's still overall time complexity of n. And then the space complexity, we're not really storing anything in a memory besides some variables, which will just be constant space. And so this is the solution I have. So do you have any questions online?
No, I think I'm good.
Okay,
Yeah. So
I'm gonna run this. Great. I think I did kind of mess up. Well, I think my explanation while I was implementing it was a little confusing, but I hope I was able to clarify what I was doing as I was finishing up.
thank you very much for this interview.
Do I pass?